right, welcome back. We are COMP2142, that's Game Artificial Intelligence 1 in the winter 2026 semester at Georgian, and it's week 5, part 2 of our broadcast and recording. In the last part, in a very convoluted way, I showed you guys how to do a sorting algorithm in blueprints, right? And I say convoluted because it didn't quite work out the way I wanted to, but that's okay. Sometimes we troubleshoot and we make things work, and other times, well, live coding is live coding. Let's get back to what we really want to do today, which is the Unreal Lab for setting up our start pawn for obstacle avoidance. So how do we do that? So first I want to go to my start pawn. So let's go there. And I want to open that up. And this is where we're going to do some of our changes. One thing that we notice is that there's all these begin play and parent begin play and event actor and parent. And the reason why this is happening is because start pawn inherits from base pawn. You can see that up here. For now, let's just get rid of these. We don't need these associations, right? Because really base pawn doesn't have an event graph. If you actually look at the event graph for base pawn, it kind of looks like empty, like this. So actually we can get rid of this too, right? Because we're not really doing anything there. So that's base pawn. So because base pawn and start pawn, I mean, they have nothing. Same thing with enemy pawn. You can see that if I open up enemy pawn, it has all this, and we also have, the gold pawn, which has all this stuff. Because we're not doing anything, we don't really need to, include those things, because it just is waste for us. So we don't care about that. Now let's go back to the start pawn. So in our start pawn, what we want to do is we add in some variables, and one of them is whisker length max. So let's go back to that, whisker length max. And this one is an integer, I think. Let's make sure. It is a float. So this is float. And compile and save. And what we want to do is we also want to add in whisker length. And debug, which is a Boolean. As well as enemy pawn, a reference to the enemy pawn itself, which is just a reference to that. So BP underscore enemy pawn object reference. There we go. Let's make those open up. And then once we do that, what we want to do is set a value of 1000 to whisker length max and 300. So again, 1000 here. Again, you can change this value if you think that that's too small, but I'm just making it so that you can, as a demo, minimum would be 300. You can also make this whisker length a different number starting off. All right, so that is the things we have there. And then what I want to do is in the grid character, let's go back. So this is start pawn. Let's go to the grid character now. So compile and save. Back to grid character. We don't have to do this. This is our bubble sort example. I'm just going to get rid of this. So that's what we just did for that. I'm just going to remove that execution pin because we don't need that in there. And then what we need to do is two variables, avoidance direction that we're going to use. And this avoidance direction is a float. And it's not an array, it's a single, and it's instance editable. We want to make this available to us. And then there's obstacle detected, which is also a Boolean. And that's also instance editable. These two things are part of steering properties, so we'll add that in. So steering properties, and also part of steering properties. There we go. Compile and save. Well, once we have all that, then the next part is, in our event begin play. Yep, in our event begin play of, what we want to do is we want to modify our, and this is, by the way, event begin play of the start pawn, right? We want to get a reference to the enemy pawn. So again, start pawn. Event begin play, so we can type that in. Event begin play, and we want to get a reference get actor of class and we want to get a reference to BP underscore enemy pawn, and we want to set the enemy pawn to that. There we go. So we can kind of do one of these and set that up nice. And that's the only thing we're going to do there. Next, we're going to use our whiskers for raycasting, and the start pawn as it steers towards the goal pawn. We want to make a new function called configure whisker. This is kind of a big function. Again, there's many approaches we could have taken here when I created this, but you can see that there's a lot of inputs. I'm giving you this as one possible way of doing it, but there's other ways. So grid character is what we want in here for whisker. So grid character, which is a grid character object reference, BP underscore grid character object reference. And then it's start, forward, and right vectors, which are vectors. So start, forward, right, which are vectors, right? Start, forward, and right, and we can call this forward vector, right vector. I'm just going with what we have there, so we can see that those are the things that we have there. Let's make sure that they are correct, just so that way there's no errors in what we're going to do. Whisker length and whisker angle are two floats. So whisker length and whisker angle are two floats. Whisker angle are two floats. There we go. And finally, debug is what we're going to pass in. Debug. Do we want to show the debug or not? Basically, do I want to show the whiskers? So that is your inputs for your configure whisker function. Local variables we want are angle in radians. So we're going to say that angle radians is a float type. Forward weight and right weight also floats. Forward weight, right weight also floats. Today is one of those days. There we go. And whisker direction and whisker end, right, are the two vectors. So whisker direction and finally whisker end are two floats. So that's something that we're going to have. So I've set up these local variables as well. Next, what I want to do is we're going to set this up in a series of layers. So we're going to have a sequence node, and the first thing in the sequence node is we're going to get our whisker angle, and we're going to go from degree to radians. So whisker angle, so get whisker angle, and we're going to go from degrees to radians, D2R, and then from there we're going to save this as angle in radians local. Right, so that's the first thing we're going to do. So we're setting up some values, and the next thing is angle in radians. Angle in radians, we're going to get the cosine of this, and we're going to say this as forward weight. So angle in radians, we're going to have the cosine weight, and we're going to call this the forward weight. There we go. And the next one is angle in radians, sine of angle in radians. So angle in radians, sine. And we're going to call this the right weight. So just to give you an idea of what this is, what I'm doing is actually, and what angle in radians is the angle that we, the whisker angle itself. So let's say if the whisker angle is 30 degrees, right? So it's in degrees. We're going to convert it to radians, and then we're going to say whatever that value is, we're going to pass this to the cosine function. So it gives us a value, and it's going to give us the difference between, like, we're going to basically, Pythagorean theorem, we're going to calculate, kind of from where we're looking to the right or to the left, depending on the sign of the angle, right? That's what we're doing here. And then this is the whisker direction. So what we're going to get is the forward vector. So get forward vector, this one. And we're going to multiply it by the forward weight. So this is where we're actually scaling it by, because we're trying to figure out what the forward weight is. It's almost like we have our own normal, a new normal, whatever that forward direction is, right? And what we're going to do is multiply or add it to the right vector, right? So again, we're basically drawing little triangles, right? So adding it to the right vector, right weight. So right vector get right vector, and then multiply by right weight here, and that's going to give us the whisker direction. And these two are supposed to be vectors, like I said, not floats, Tom. Yes, there we go. Vector is vector direction, so that's this. And what this does is it sets up some variables for us at the beginning, this first, sequence that we just did. This part right here is all setup. So this is the setup initial values for each whisker. This is for each whisker. So setup initial values. There we go. Setup initial values. And we're going to kind of type that in there, and we're going to do one of these. There we go. Next, what we want to do is we want to configure the whisker endpoint. So we're going to get the whisker direction and normalize it. So whisker direction and then normalize, because the direction is the whole vector length, right? We don't want that. We want the normalized value, which is the unit length. By the way, if I go to vector unit, unit direction, this is kind of interesting. This is another little note I found out. From to, it'll give you the vector length. It'll give you actually a vector length from to. So I have to have two vectors, the where I'm going to from and where I'm going to, and that'll give us the unit direction, which is kind of neat, right? But it's kind of a shortcut. And what I want to do is I want to get that whisker length. So get whisker length. There we go. And that whisker length is something that I'm going to multiply by the normalized whisker direction. Multiply. There we go. And then what I'm going to do here is I'm going to multiply that by the start. So I added to the start. I added this on to the start. So it gives us the kind of the get start. So the start being the starting part of wherever this vector starts. It's going to basically draw, the whisker direction is going to, we're going to take that and we're going to multiply it by the whisker length. So we're going to kind of, shoot out a ray. That's what this is going to be. And it's going to start, at the starting position of where the ship in this case starts. That's where it's going to be. From the start of the ship to whatever the direction is, that's where I'm going to go in that direction. And that's going to be the whisker endpoint. That's what I'm going to kind of calculate. So whisker endpoint, monkey. And that's what this does. So this kind of computes or configures the whisker endpoint. So configure whisker endpoints. There we go. And then the next one is I want to check to see if the line trace hits the grid character. So we're going to get I want to make line trace by channel. So line trace by channel. There we go. And I need the start and the end, so I'm going to get the start. And then this is the whisker ends, right, which we just defined. And what we're going to do here is we're going to check to see, and this is something we're going to have to confirm next week because we're not going to do that this week. This is check if line trace hits grid character. Check if line trace hits grid character. Whatever that grid character is going to be. So if that's true, right, we're going to break out the hits, break the hit result. The hit result is going to have, if there's a blocking hit, so branch. So if we hit something, that's what this means. It doesn't matter what we hit here. We hit anything. Then what do we want to do? Want to get the hit actor and cast it as a BP base pawn. So hit actor, cast to BP underscore base pawn. That means it could be any pawn that I'm hitting, right? So there we go. And actually, this is more accurate to say check if line trace hits a base pawn. That's what that really is. So it could be any kind of base pawn, enemy or gold pawn or whatever, right? So that's the first thing. And then I want to get the base pawn's cell state. So get cell state, because remember all pawns have a cell state, whatever that is. And I can switch on cell state. So switch on E cell state, because it could be start pawn, the gold pawn, the enemy pawn, or a patrol type pawn, which we haven't set up yet. And I want to basically say that if the whisker length sign, so whisker length, so if the whisker angle sign, get whisker angle, and then what I want to do is sign, if that sign is not equal to 0, not equal to 0. So what I'm checking for, if it's not a forward-facing whisker, like the only one that goes like straight forward, so 0 angle, then I'm going to do one of the two things, branch. And I only check for the enemy. That's all I want to check for, because I want to avoid the enemy pawn right now. Because this is what this is going to do, avoiding the enemy, a collision, collide with the enemy pawn, right? If that's true, then what I want to do is, if it's true that it's not equal to 0, then I want to do an avoidance direction. So if it's true, that means I want to get the whisker angle, and I want to get the sign of that. So whisker angle, sign. And then I want to set the avoidance direction to that. So, so that's what this is, set avoidance direction, set, but it's got to be set avoidance direction of the grid character. So get grid character, set avoidance direction to this value, whatever that value is, right? And that's the first case. That means if it's not true, or sorry, if it's true that it's not equal to 0, so it's some other angle, right? Otherwise, if it is equal to 0, what do I want to do? I just want to use that, you know, the avoidance direction is 1, which means there's no avoidance direction at all. It's just right in front of you, basically. So I'm setting the angle to 1. There we go. And that's this. Okay? So that's the false case. People call at the wrong times. Let me call you back. All right. So that is what this part does. So this part is, basically check if the line trace hits the base pawn, and if it does, calculate the avoidance angle, whatever that's going to be. Okay. And the last part is if I want to show the debug trace or not, right? So if I add that in, then what I want to check is to see if debug is true. So if debug, get debug. And if that's true, branch. If that's true, then what I want to do is I want to draw a debug line. Draw debug line. Here it is. From start to whisker end this time. Start to whisker end. I can choose a line color that I want. I'm just choosing red for my line. You can choose whatever color you want for your lines for your whiskers. And the duration is 0 because it's going to draw it every frame. So this is going to basically show trace line if debug is checked. Show trace line if debug is checked. All right. And then this can be something made nicer like this. And that is our first function. This is our configure whisker function. Okay. Now, the next part is update whiskers. So what I want to do here is I want to make a new function, update whiskers. And the update whiskers function is going to also have some local variables, but no inputs. Okay. So we want a z offset, which we're going to call floats. And we're also going to have a bunch of vectors, start, forward vector, right vector, up vector. Start, forward vector, right vector, up vector, right vector, up vector, and then a grid character. We're going to get a reference to that. So grid character, which is of type BP underscore grid character object reference. BP underscore grid character object reference. That's what that is. And then whisker angles are the float. So whisker angles are the float array values that we're going to make right now. There we go. Compile and save. So that's an interesting way of doing it, where we have a bunch of variables like this, but they're local variables. And what we can do is let's build up the update whiskers function. So the way to do this, we're going to get actor of class grid character first. That's the first sequence. Get actor of class, and then we're going to say BP underscore grid character object reference. There we go. And then we're going to say that let's save that as the grid character local. And then what we want to do is we want to avoid, the avoidance direction is 0. So we're going to say that set avoidance direction as 0. Okay, that's by default what's happening there. And what we're doing here is we are get and save reference to grid character, set the avoidance direction to 0. Get and save reference to grid character, set avoidance direction to 0. There we have it. Next step is I want to set the initial value. So I'm going to say the starship mesh, right, which is this one, spaceship mesh. We want to get the relative location. So get relative transform. Well, if I go location, get relative location is what we want. And I want to break this. I want to kind of split the struct pin so it looks like this. So there's a relative location. I want to set the X to the Z offset, and I'll explain that in a second. So the Z location is going to be the offset that we're going to use when we, we're going to use this as the location for where the whisker starts. And you're going to see that how it works. And we're going to get the actor location, and the Z offset is going to be equal to the X value of the spaceship mesh, right? So that's what's happening there. And then the X and Y are going to be zeros. So that's what we're going to do. So we're going to get actor location, get actor location. There we go. And I want to add, that's happening. And I want to add in, kind of if I kind of split the struct pin again, you're going to see I can add components individually. And I want to get that Z offset, and I'm going to add that in there. So that's the actual location. And then what I want to do is with that actual location, that's going to be the starting location. So that's we're going to set the start to that. So it's a bit of an offset we're going to use. And that is the starting point of the whisker. So whatever the location is, we're going to say that is the offset location, that we're going to start where the start is. Okay. From there, what I want to do is I want to get the actor forward rotation. So get actor forward vector. That forward vector is going to be saved as the forward vector. So temporary value. Because I don't want to do that all the time. Forward vector, forward vector. And then the right vector is get actor right vector. We're just going to save that as the right vector. And all it is just an alias. So instead of saying get actor right vector, we're just going to say right vector. That's all these are. And then up vector, same thing. So get actor up vector. And that's going to be just the up vector. So these are just initial values for all these things that we need to pass in. So set up initial values. Okay. Once we have the initial values, then what we want to do is generate all the whiskers. Let's do that. So we'll say whisker angles, and we'll say that we want to say that for each loop, we just did this crazy for each loop, for each, there we go. And we want to say that for every whisker that we define in whisker angles, I want to do all this stuff. I want to configure the whisker. So that configure whisker, function we made earlier is what we want to do now, right? So I want to get the grid character, which is this, pass into the grid character there. There's that. That's what's happening there. And then start forward right is what's going to be there. So start forward right are these. Whisker length is going to be the whisker length. That's the actual whisker length from the class variable whisker length. And the whisker angle we're going to get from the array element. Whatever that array element is, that's going to be the whisker angle we're going to use. So you're going to see where we're going to get these in a second. And finally, debug, we're going to pass through debug. So we're going to say debug, if that's true or not, we're going to pass that into debug. And that's for every angle, every whisker angle we define. Now, we haven't defined any whisker angles, but we can do that. So here, we can add in a bunch of angles here. Let's add 13 values. So we can add them in. And then the first value is 0, so that's right in front of the ship. then 15 degrees to the right, and 15 degrees to the left, minus meaning left of the ship. 30 degrees to the right, and you can have less than these if you want. I'm making this happen so you can see what it would look like if I had multiple whiskers. You can only have 2. You can try it these ways if you want, but I'm showing you if I was going to try a bunch. Instead of 2, I'm going to get 13 to see what that looks like. Now there's reasons for this, because again, what we can do is we can reduce some of these, and we might actually have a better effect, because the more of these we have, the more checks we're doing. Although it may seem to be more accurate, actually what it can do is cause more issues, right? So we'll see that. And this part is generate whiskers. So generate whiskers. There we go. Okay. Compile and save. All right. Look at that. So this is our generate whiskers function, but we never called it. Let's call it now. So we'll have 2 little things inside of our 2 utility functions for UI elements we're going to define. So one is get whisker length percentage. So we'll have that, get whisker length percentage. And what this is going to do is take the whisker length and divide that by the whisker length max. Divide by whisker length max. So whatever the current whisker length is what we're going to do. And then we're going to return that as a add return node as the percent. That's the percent that we're going to return. Okay, so it's a little utility function we're going to use for user interface stuff that we're going to do in a bit. And the other one is we're going to call that set whisker length percent. So getter and setter pair. So let's add that in. And set whisker length percentage to the percentage we're getting in. So inbound, there is a percentage, which is a float. And then we're going to take that percentage and we're going to whisker length max multiply by that. So we're going to multiply that by whisker length max. Kind of what we did actually in the multiplayer part this week, where we kind of said if I already have a percentage and I have a whisker length max, I can come up with a current value, if you will, for these things. And that's what the whisker length is. So set whisker length to that. Let's try this. Yeah. All right. So a couple of utility functions here. I'm just going to shut all these down as we've done so. And then what I want to do is let's connect our update whiskers to our event tick. So I'm going to go to our event graph and let's go event tick. And what I want to do is update whiskers. So let's go to that update whiskers function right there. Okay, compile and save. Now, just to check stuff, let's put our debug for now. Let's set that to true so that we're always checking to see what that whiskers looks like, and it kind of looks like this. So now if I press seek, you can see that it'll work the way it is, and each whisker, just to zoom in, will stay in the correct position. And that's the idea. Just to show you this one more time, let's press play, and this time I will set the step delay a lot higher so you can see it happen in real time. And if I push seek, then as you can see, when the ship moves forward, each whisker also moves along with it in the correct angle, right? Which is important to do. When the ship moves and turns, you can see that the whiskers change direction as well. And imagine that these are all these rays that I've cast in front of the ship, right? Now this is definitely a way of doing it, following our thing. So if I was going to detect to see if these were intersecting, one thing we could do, because right now we're looking at it as in a perspective mode, but we can, or sorry, top mode, but we can kind of go, if I go into perspective for a second and check that out, well, it flips us to this mode anyway because our camera is the way it is. But let's go back to top for a second. what we're going to do is we're going to shift out of this. We're going to pause this, right, as we come closer. So let's do that. So we'll say go there, and then if I go to seek, so I press the seek button, then when I come closer to there, I want to pause this, right, as an example. And the beautiful thing is if I pop out of here, right, kind of thing, and if I go into perspective mode, then we can see where the ship is relative to this thing. So you can see here, even if I cast a ray out of the ship the way it would be, we can't see the ray right now because we've paused the simulation, but the ship will kind of miss the world, in this case the planet, right, because it's casting a ray from the front of it onward, right? However, let's go back to show you that again. So if I was to do this, and I pop out of control for a second, let me show you this. Oops, sorry, I'm going to lose my perspective because I'm in perspective mode. Take a look at where it actually is casting. So this is that offset, that Z offset that I'm casting out from. So even though it shows where it is, the Z offset is actually happening at the base of this thing altogether. See that? So this is an issue, right? And I'm pointing this out because this is where the ray is casting. It's almost like I'm casting down over here, and then I'm trying to connect with something. So if I was trying to avoid this thing, these rays are actually like right at the base of where this thing is, okay? That's where each of these rays are being cast, like way down here. You may not see it, and I'm kind of showing you at this weird angle, and the reason why is because I'm in perspective mode, but you know, it looks like I'm right on top of it, but actually, again, if I go back to perspective mode, you can clearly see that we're actually, we're actually below it, like down here. This is the ship, and then down here is where it is, right? So why? Why is this happening? Well, when we do the collision detection, right, eventually what we want to do is we want to have that offset be correct, right? So let's talk about this for a second. So go back to the start pawn and think about why I'm doing that way. So if I go back to update whiskers basically says, okay, so here's my little offset, my Z offset, right? Here's my Z offset. My Z offset right now is 0, right? And I can, I'm getting the relative X position, you know, for this thing, and that's what I'm printing out the entire time. The relative X of my ship, right? My spaceship mesh, right? And the relative X, right, is position 110. Sorry, is position 4, right? So what if this is wrong and I did this? Let's just, you know, I mean, I'm relative Z, I'm using that as a Z offset. Let's see if I did that. And if I press play again, right, and I'm going to zoom in now, and let's see what that looks like when I'm into, you know, kind of when I kind of zoom out of there. And I want to go into the perspective mode now. Now this is more like it, right? This is what I want to do. So I wanted to show you this because just so that you know that this may intersect with, sorry, just make sure that I'm seeing this, the same level. I know it's kind of weird, but it's really weird because of my perspective. See how this is actually touching? We're actually getting an intersection here, whereas before it wouldn't intersect at all. So it seems that there is an error, and that this is what we're looking for. Z offset is the relative Z. When I saw this, I was like, huh, I don't know why I put that in the PowerPoint. It actually should be this. Okay, so that's why I wanted to show you that. Let's go back and go to top, and then we're good. So that's the first thing. So that has to be changed. The PowerPoint shows what it showed, but that was incorrect. Next, now that I know that this is the case, that I'm actually able to cast whiskers, I want to add that part to the user interface, and then we will be done with today. So patching up our HUD, I want to add another line. Let's go back to that. So back into our UI, and this is our overlay, right? And what I want to do is I want to duplicate this one. So duplicate, and I want to pull this one down approximately here. One thing that we can do is we know that 56 and 148, 224 and 30, right? So the X position should be 56. This is correct. But this position can be offset. We also want to call this the whisker length label. So whisker length label. There it is. We don't care if it's a variable, whisker length. And we do want to duplicate this as well, which is the step delay slider. We want to duplicate that, and that'll be our whisker length slider. That definitely is what we want. We want to make sure that the X position is 285 for this one, so 285. But the Y position is going to be somewhere here. Okay. And then finally, we want to duplicate, and this one, but whisker length slider has to be a variable. This one is also duplicated, and again, we can see that the X location is 545, so we want to make that one 545 as well. And this will be called the whisker length value, and then we're going to pull that down to about here, and we're going to change the value that we see there to about 1,000, just so we can fit it in. I added the comma in there just so that we can see what it would look like if we had this kind of our sizing or prototyping. Now we want to add in something else. We want to add in a debug label. So let's just copy this one. So duplicate it. And again, I want to put it somewhere over here. I want to match what this is. So this is at 56 position. So this is also should be at 56 position. This will be the debug label. Debug label. And it should say debug question mark. Debug. And then what we want is a new thing, which is a checkbox. But the checkbox is going to be inside of a scale box. So first, what I want to do is get a checkbox. It's quite small, as you can see, right? And the checkbox, I want to surround this by, kind of a size box, right? So notice this, or a scale box. So I can right-click on the checkbox, and I can go wrap with scale box. And when I do, it kind of makes the size a little bigger, right? One thing to note that the scale box itself, make sure that the Z order is 2, because otherwise we won't be able to check in that at all. And then you can scale this down so that it's something like this, right? So you can change the scale. That's what the scale box does, is it allows you to scale objects bigger or smaller as you see fit. I want to make mine kind of a little bit so that way it fits and it looks nice. Also, one thing we could also do is we can move the whole thing around so that it matches the corner here, so it looks nicer when it comes to user interface design. Alright, so the other thing is that this should not be called a checkbox. This should be the debug checked. So debug checked, and then is variable is true. So one thing I did was I moved this by accident. I'm just going to undo those changes. Still move them, right? Yeah. So one thing to do is you can always go to the background, all these things here, and you can lock them. So if you lock the background, then if I click this part, I can move it around without the fear of hitting the background or the border by accident, so we can also lock that up, right? And so this way I can't by accident click these things and move them around, which I did earlier. So I want to do that again, kind of pull that in there. And this will be scale box. I didn't change the name of that, just scale box. And checkbox should be debug checked. I undid that, that's why it changed things. There we go. And definitely want to decrease the size of that a little bit and put it in place, because I think it's got to be smaller than the words a little bit. Something like that. Like kind of the same size of that G, that first part of that G, something in that range. Right? All right, that's it. So compile and save. And now that we have our user interface, we should test to see if you can see it and click on it. I can click on it. That's an important part. Otherwise, if we can't click on it, you'll never be able to turn on and off our debug. Also notice that our start pawn, we had our debug checked on. Let's check it off. And so we'll have to check it for the first time when we're using our user interface. When I check this, I want the raise to be shown. Otherwise, I don't. Okay, and then the next part is let's add in the event construct function of our user interface, so this part, under the event construct, which is way up here. Let's make some room. So I'm going to just take the event construct part and move it up. Something like that. And what I want to do here is add another pin. Let's make sure that this is coded like we like. I guess I left it that way last time. I want to get the start pawn. And what I want to do is I get the whisker length percentage. So there's a start pawn. So get start pawn. And I want to get with whisker length percentage. So get whisker length percentage. There we go. And that is what I want to set in the whisker length itself. So whisker length slider, I'm going to set that value. So I'm going to get the whisker length slider and then set value to whatever that whisker length percentage is. Because that makes sense. Okay, and that is going to set initial whisker length and the slider value. Set initial whisker length. Slider value. And let's just make that white color. Pull this down. It's actually a shade, but whatever. That's the first thing. So that'll set the initial length so that it's right. So if I was to compile and save and go back to play, then we'll see that the whisker length is the correct whisker length. This value, this on the slider. The other thing that we want to do is we want to set the on the value changed. We want to do that as well. So on value changed for the whisker length slider. That's this. So whisker length slider, and then if I go to on value changed, it'll add an event. And what I want is I want to get the start pawn, get start pawn, and I want to set the whisker length percentage. So set whisker length percentage to whatever I've set it to, whatever that new value is going to be. I want to do that. So that is going to be, that's because when I move the slider, I want the actual whisker length percentage to be changed in the start pawn. But I also want the start pawn's whisker length. So I'll get start pawn. And then I want to get the whisker length, get whisker length, whatever that new whisker length is. And I want to get the whisker length value, which is the text. And I want to set text to this. Now we know that if I just did this, because we did this last time, that we're going to have some cockamamie values. I don't know if there's a better way of saying it, but we're going to get some weird values here. And one thing is, whenever we do a setter or anything like that for whisker length, to make sure we didn't have anything else up there, we want to kind of guarantee that these values are whatever they are. So whisker length is going to be, the maximum integral digits might be 5, you know, as an example, 1, you know, plus a comma and 4 values, so 3 values is 5. The minimum integral digits must be 1, right? The fractional digits minimum is 1. If we're going to do fractional digits, and the maximum is going to be 2. Okay, that's what we want. And that's going to set up our percentage for the first time. So what this means is, when I press play, this is whisker length 300. And if I was to move this thing, you can see that as I move forward, that whisker length changes to whatever the value is I slide to a maximum of 1,000. Right? So that's what that does. Next, on check state changed. So this is where on check state, so if I go back to where is it? Here it is, debug checked. So if I go to on check state change for debug checked, then what I want to do is I want to get the start pawn, and I want to set the debug, there we go, to whatever this check state is. So if it's on, it'll show it. If it doesn't, it won't. So let's try that out. So press play, and then now if I click this on, you can see that it turns on or off dynamically, which is kind of what we want. So this kind of set up our user interface. And that's what I wanted to do for today. I just want to set up the whiskers. I know it takes time. It took us another hour to do or so. But I wanted to set this up because now that we have the whiskers on and they've been set properly, then we can do the next part, which is the avoidance piece, which we're going to do next week. Okay, so that's it for me. Guys, thank you for being so patient with me. Hopefully that answered some of your questions and helped you prepare for assignment 1B. And even with my crazy explanation of or tried to get the, you know, your algorithm working with some issues, but that's what happens when you live code. You know, I want you to take something out of that, which is, you know, the things I talked about. So hopefully that helped you. And again, I appreciate the patience you guys had with the asynchronous recording. It's not as nice because then you have to watch it again, 3 hours. You can zip through the other part if you want as well. But at least you have everything you need for your assignment. And again, I'm thinking about moving them off. We'll talk about that when I see you guys on Wednesday. Again, just one more thing, that this week coming up, which is week 6, is a remote week that's planned, so we'll be together remote. Okay, guys, thank you so much. Enjoy the rest of the weekend, and I hope to see you next week.